Hello everyone. Before I proceed with the next example, I just want to quickly mention that I made minor updates to the template notebook file since recording the previous video for this lecture. Go ahead and pause the lecture video here and download the updated version of the template notebook file if you want to include the recent changes. For the next scatter plot example, we'll be analyzing the iris dataset. Iris dataset is very famous in the world of machine learning. It provides a description about iris flowers by mentioning attributes like sepal length, sepal width, petal width, and class of the iris flower. There are three different classes associated here. I'm quite sure all of you know what a petal of a flower is. A sepal of a flower is part of its calyx, which is the tiny green leafy part that comes below the petal of a flower. This page itself provides a description of the iris dataset. Let me show you how you can manually download the dataset. Click on the data folder and click on iris.data, and that will download the dataset manually for you. We are not going to do that. Instead, we'll be using the request module to download the iris dataset for us. Recall that the request module get function enables us to send HTTP GET request to a specific resource which is mentioned using a URL. URL for the iris dataset is mentioned as part of the previous markup cells description. I'm going to just copy paste that in here. Recall that request module get function returns a response object. I'm going to capture that into a variable called R. Once again, always use meaningful variable names. I'm using R here just because it will be easy for me to type. I would recommend using response instead. The very first thing that we need to do whenever we send a HTTP request is to confirm whether we got a 200 OK response. Recall that we can do that by saying r.raise for status. This particular function asserts that r.response code is 200 OK for us. Let me go ahead and run the cell. All right, what should we do next? The first thing which I want to mention is the iris.data file has a CSV file format. So we are going to just open a new file called iris.data and we are going to dump the response text part into that file. I'm going to use the open function. The first argument should be the name of the file, so that's going to be iris.data. The second argument should be w because we want to write content into the file. And I'm going to capture the return value into a variable called iris_fh. Before I do anything else at all, I'm going to go ahead and close the file handle over here. So I'm going to write r.text into this file. So I'll have to say iris_fh.write and r.text will contain the response text. Once we download a local copy of this dataset, I'm going to use the pandas read_csv function to read the content of this CSV file. Recall that read_csv function returns a data frame, so I'm going to capture that into a variable called df. One thing which I want to mention here is that the read_csv function in pandas is capable of reading CSV format directly from a URL, but unfortunately this particular URL doesn't work because of some SSL certificate issue. That's the reason why we are manually we are automatically downloading the dataset using the request module over here. Let's take a peek at this data frame. Recall that you can do that by saying df.head. Let me go ahead and rerun this cell. We are getting the dataset, but one weird thing about this data frame is that the very first row of our dataset is showing up as the column names, correct? That happens when your CSV file does not have a header line, which is true for this particular dataset. So what you need to do in those cases, you need to explicitly mention the list of column names for each of the columns. You can do that by passing argument to a parameter called names inside read underscore CSV function. As you might be able to guess, this particular parameter takes a list of string as an argument. I know what the names of the columns are for this particular data set. So I'm just going to go ahead and type that. I'm also going to move the names parameter to the next line just by pressing enter. I can do that because anything within parentheses in Python can be split across multiple lines. Let me type the names of the columns here. The first column is sepal length, so I'm going to say SCP-length for short. The next one is sepal width. The one after that is petal length. The one after that is going to be petal width. And then finally we have class of the iris flower. Let me go ahead and finish typing that, and then we can take a peek at the data frame one more time. Alright, that's so much better now. We have the correct column names. Let me also show you df.tail so that you can look at the last few lines of the data set here. Notice that we are seeing different classes of iris flowers when we do a head and a tail here. So this particular data set contains entries for 150 iris flowers. We have 50 entries for each class. Recall that we have 3 classes. The next question over here is asking, how do we create a scatter plot for various class types? So clearly, first we need to extract the unique classes over here, right? Recall that you can extract one particular column in a data frame just by saying df of column name. So I can simply say df of class over here. Just like we can convert a series into a list, which is what I'm doing right now, we can convert a series into a set directly, and that's going to give us the unique values present inside that particular column. And I'm going to capture this return value into a variable called classes, and let me display classes instead. All right, we have the unique class types. The next part of the question is asking, how do we create a scatter plot for various class types? So there are so many attributes here which we can use. We can potentially create one scatter plot which compares the relationship between sepal length and sepal width, and another one which compares the relationship between petal length and petal width. And you can think of many other combinations with 4 of these attributes over here. We are going to use the comparison between petal length and petal width. And the natural thing for us to do is to plot the petal width on the x-axis and the petal length on the y-axis, just because those two axes typically represent length and width. Let me go ahead and first extract one class, and then we can worry about how to create a scatter plot for all of those class types. Recall that you can extract one class by using a Boolean expression because we have a pandas data frame over here. So I can simply say df of class equal to for the last class, for example, doesn't matter which one you use here. And this particular expression is going to give us a Boolean series. We can take a Boolean series and apply it back to the data frame. That will give us the subset of the data frame that satisfies that particular Boolean series. Looks like we're getting about 50 rows. What we want to do next is we have part of the data frame which just contains one class of iris flowers. We just want to go ahead and create a scatter plot, correct? So I'm going to say dot plot dot scatter, and recall that you'll have to say what is x and what is y here. For x we are going to use petal width, and for y we are going to use petal length. Right, looks like we do have the scatter plot over here. So if we want to do the exact same thing for all the classes, we need to iterate over the different classes, correct? we already have the classes captured into a variable called classes. So I'm going to write a for loop. I just want to let you know that class in Python is a keyword, so you should stay away from using a variable name like class. But we are not going to learn what class represents, at least not as part of this particular course. So I'm going to say for variety in classes. First, let me go ahead and print variety before I do anything, just to confirm my for loop is working. Perfect. I would always recommend you to incrementally test your code like this. So I pasted the previous cell's content over here. Instead of saying iris virginica here, we need to say variety. And let me go ahead and run the cell here. Notice that we are getting three different plots representing each of those class of iris flowers. Let's talk about what is wrong with having three different plots. Notice that the x-axis range is very different for each of those plots. For the first class, the x-axis range is from 1 to 1.8. For the next one, it's 0.1 to 0.6. And for the third one, it's 1.4 to 2.4. It's very difficult to make any meaningful comparisons between the classes if we plot them separately like this, correct? So let me show you how we can fix this and plot everything within the same figure. Before we go ahead and go through the code for that, I just want you to get a sense of how you can use axis subplot to do this particular merge of all three plots together inside the same figure. Recall that axis subplot enables us to set various aspects about the plot figure, including things like x-axis label, y-axis label, title, text, and so on. Axis subplot object is very powerful. Every plot function takes axis subplot as an argument inside the parameter called ax. So if that argument is passed, then the plotting is done inside that axis subplot object, which is that particular plot space. If the value of the passed parameter, passed argument for the ax parameter is none, then the plotting function automatically creates a brand new axis subplot object and then plots the content into that axis subplot object. The third thing which you need to know is that every plot function returns the axis subplot that was used by that particular plot function. So we are going to leverage all of these things over here to fix our code. So I'm going to, let me paste the content from the previous cell. Give me just a second. All right, so I'm going to define a variable called plot underscore area outside my for loop, and I'm going to initialize this to a value of none. So this is going to be very similar logic that we apply when we try to find a minimum of something or a maximum of something while iterating over a list. Recall that we used to create a variable outside the for loop and initialize it with none. And in the if condition, we'll include a check saying if that variable equal to none, or some other min or max condition, then assign some value into that variable, correct? The only thing is that the plot function automatically takes care of checking whether this particular variable is none or not. And I'm going to be passing the parameter plot underscore area into, the argument plot underscore area into the parameter ax over here. Recall that I need to capture the return value into the same variable to make sure that we are able to update the axis subplot variable over here. Let me go ahead and run the code now. Oh, something is missing. Oh, I used a different variable name. Let me fix that. All right, now we have all the classes plotted in the same figure. The figure is still very much unreadable, right? Let's go ahead and fix things by adding color and shape to each category of classes. I'm going to do that by defining a color list and a marker list. So I'm going to define 3 colors and 3 markers because I know that there are only 3 classes over here. And I'm going to say the colors are blue, green, and red. We haven't covered markers before this particular example. Marker is the part of the plot that controls the shape of the plotting point. You have circles as the default. So the circle can be represented using O. And then you have other things like triangle, which you can type by clicking on shift and clicking on the number 6 on your keyboard, which gives the uptick for you. And then the V represents the lower half of the triangle over here. So I'm just going to use 3 markers. You also have things like plus and other kind of markers. Feel free to explore all the markers available for you. So one iteration of this for loop plots one set of points corresponding to one class, correct? So the very first iteration will have plot underscore area as none, and you'll go ahead and create a brand new plot access subplot object, and then you'll be returning that into the variable plot area. So subsequent for loop iterations will be plotting in the same access subplot over here. So one iteration deals with one set of points, so which means that we need to use one color for that, right? There are many different ways to do this. Since I'm not going to be reusing colors or markers list for any of the future examples, I'm going to use the pop method call. Recall that pop method call in a list takes as an argument the index position. So if I say colors.pop of 0, that's going to return blue to me, and it will also remove blue from the original list. And I'm going to follow a similar thing for setting the marker as well. So one thing which I want to highlight is I would recommend you to not use different aspects of the plot to represent the exact same variation, but I'm going to show that just for the sake of example. And finally, to plot the legend, we need to use the parameter label. And what should be the legend? That should be the class itself, right? So I'm going to say variety over here. If I go ahead and, oh, I forgot to mention color equal to, and I should say marker equal to. All right, that will be the final version of the iris dataset analysis. I'll wrap up this video here. In the next video, we'll start talking about line plots.